Why does stepper eyewear sell so well? We create frames that meet the medical needs and emotional wants of the wearer. A frame needs to hold the lens precisely and consistently before the eye to deliver the required vision correction. Stepper eyewear understands the form of the human face and works with materials and manufacturing processes that deliver outstanding fit. In addition, due to differing facial characteristics, frames need to sit accurately on the wearer across ethnicities. Before we move on to materials, manufacturing, and facial characteristics, consider the relative power of medical needs versus emotional wants for eyewear and the impact this has on frame selection. Medical needs, vision correction, lens size, holding lenses correctly, correct fit, allergies, emotional wants, confidence and self-esteem, identity and self-expression, comfort and effortlessness, freedom and independence. For the customer, emotion is a key motivator. The eye care professional understands the importance of fit. This imbalance can cause the customer to be motivated by their emotion over professional advice. The result? Potential disappointment with vision correction. Remind the customer that a frame is a medical device to hold prescription lenses correctly before the eyes, not a fashion item. Great fit and outstanding styling meet the medical needs and emotional wants of the wearer. To deliver the perfect fit, the frame material selection, the required advanced manufacturing know-how, and the expertise to create designs to match the facial characteristics for all come together within stepper eyewear. Materials and manufacturing. Frame material selection is fundamental in creating frames that fit due to their intrinsic properties and therefore suitability. This necessitates specialist manufacturing processes to make these materials perform as required. TX5 and acetate. For plastic frames, it is important to differentiate between stepper eyewear's TX5 and regular acetate. Both are a plastic product. Both are quite different in their manufacturing processes. Both have distinct characteristics that differentiate their suitability for eyewear. Acetate, not used by stepper eyewear. Cotton fibers and tree pulp formed into large blocks, 1 meter long, 0.8 centimeters thick. Frame parts are cut from the sheet, heated, and bent to shape. Color is already in the material. High wastage of discarded material. Frames lose shape over time, reducing fit and comfort as they return to their original, flat profile. Acetate stages. Material preparation. Cutting the rough shape, blanking. Pressing and forming. Trimming and precision cutting. Additional forming. Surface finishing preparation. Injection molding, used by stepper eyewear. TX5 allows for a better anatomical fit, delivers three-dimensional design, is an aromatic transparent copolyamide, allows for thinner eye rims as thin as 1.3 millimeters, is stable, flexible, and strong, retains shape in hot environments. Frame parts are created in molding blocks. Injection molding TX5. Mold comes in two sections, top and bottom, to create a 3D hollow form of the part into which the heated, liquid TX5 is injected. Note, high-grade steel. 3D lens groove anatomical shape. TX5 injection molding machine. Raw materials go into the hopper. They are heated until they become liquid and injected into the mold. Molds come in two sections, top and bottom. Here you clearly see the bottom section. The top drops down to create the full 3D shape before injection. The molds have heating, electric, and cooling water to ensure the liquid TX5 flows throughout the mold and then is rapidly cooled to cure in a moment. Hinges can be put in place before the injection process to become an integral part of the frame. Lens plates are used to form the lens groove. The top mold section drops onto the bottom section, and the injection process starts. Once the liquid TX5 has filled the mold and cooled, the top section is released. This shows the 3D front in hardened TX5. The injection and curing process takes only a moment. The frame front is removed from the mold. The whole process is complete in under 1 minute, ready for the next molding. Note the 3D shape with anatomical curve and integral hinges. Frame designs with hinges that are not required to be integral have fixing holes molded in place. Fixing holes are molded in place, so negate the need for drilling, which could weaken the frame. Barreling. Parts leave the mold slightly rough, therefore smoothing is required once removed from the mold. Smoothing and polishing uses lozenges, fine abrasive powder, and oil in a 24-hour process. TX5 frame barreling. Frames tumble for 24 hours in the mixture. TX5 and acetate. Responsibility. Consider the effectiveness of raw materials required and the waste materials generated in frame manufacture. The manufacture of TX5 frame parts uses less than 5% input material compared to the manufacture of acetate frame parts. The manufacture of TX5 frame parts creates less than 1.5% of the waste created in acetate frame manufacture. Manufacture. Producing titanium frames requires knowledge, skilled staff, and a huge investment in plant and machinery. Stepper Eyewear has all of this, in-house. Titanium and beta titanium. Stepper Eyewear frames and frame components that are made of titanium or its alloys have advantages over Monel, nickel silver, and stainless steel. Lightness, less than half the weight of conventional. Corrosion resistance against all acids and alkaline liquids. Nickel-free means no allergic reactions for the wearer. Material selection and differentiation. The production journey begins with a critical decision, selecting the correct grade of titanium or beta titanium based on the performance requirements of each component. Titanium, known for its rigidity and strength, it is selected for structural components such as bridges, the central joining piece; lugs, the joints connecting frame fronts to temples; temples, the sides of the frame; precision part fabrication. Each component undergoes tailored fabrication based on its material and role. Titanium part processing. Components are stamped in multiple stages under high-pressure dies. This progressive die stamping gradually refines raw titanium into precise parts, critical for maintaining rigidity and dimensional stability. Beta titanium, chosen for its flexibility, elasticity, and lightweight comfort, ideal for flexible temples or bridges, dynamic rim shapes requiring movement or fine contour. Some designs may also integrate TX5, Stepper Eyewear's proprietary performance plastic, alongside these metals. Precision part fabrication. Beta titanium part processing utilizes high-tech methods, CNC laser cutting, for shaping intricate flexible components with micron-level accuracy. 3D rim winding, a unique process that forms beta titanium wire into ultra-light, ergonomic rim shapes. These fabrication techniques allow tight tolerances and repeatable production quality. CNC laser cutting. Filigree parts are cut out from beta titanium sheets with a CNC-guided laser. Beta titanium sheets are ultra-elastic. The laser cutting does not destroy the molecular structure. The elasticity remains, and we can get a super light, strong, and flexible frame part. .3D rim winding. Modern glazing systems require identical rim shapes and rim curves with a 0.2 mm tolerance. Specialized machines form 3D rim shapes directly from a coil of beta titanium. Advanced surface treatments. Once formed, parts move to finishing operations that enhance both appearance and longevity. Ion gold plating, an electrochemical process used for coloring and surface durability. This process offers a premium, hypoallergenic finish, resistance to corrosion and wear. This step ensures that Stepper Eyewear's titanium frames meet both aesthetic and medical-grade standards. Ion gold plating. The vacuum chamber holds 300 to 400 frames. The open vacuum chamber with frames on a carousel. The vertical part in the door is the target, 3,000 grams of 24-karat gold. The open vacuum chamber with frames on a carousel. The vertical part in the door is the target, 3,000 grams of 24-karat gold. Frame assembly and joining. With components precision formed and treated, the next step is assembly, using 4-axis laser welding, a critical process to fuse components together without the use of adhesives or screws. Offers unmatched strength and seamless integration, ensures stability and clean aesthetics. Works especially well when combining titanium and beta titanium in one frame. This method also reduces weight while enhancing robustness, ideal for eyewear worn daily. Welding. 4-axis laser welding of titanium parts. The soldering technique must be done in an inert gas atmosphere like argon to avoid oxidizing of the parts at the soldering spot and spots becoming brittle. The 4-axis welding machine allows the parts under the laser beam to get a fine seam. Barreling of titanium frames. Titanium frames are not smooth enough to convey a feeling of quality, surface feel, and value. The basic process of grinding and polishing the parts in barrels is still the best option. Titanium frames are carefully positioned in planetary gear-driven chambers containing grinding and polishing lozenges. Integration of materials. Depending on the frame design, Stepper Eyewear may use titanium for full metal designs, combine titanium with beta titanium targeted flexibility, e.g. rigid front, flexible temples, blend metal 5, e.g. TX5 fronts with titanium temples, to exploit the best properties of each. This versatility allows frames to be optimized for fit, durability, weight, and style. Final inspection and quality control. Before leaving the plant, each frame is subjected to strict quality controls, including fit and alignment checks, surface inspection for blemishes or inconsistencies, functional testing of hinge flexibility and part integrity. Only when a frame meets Stepper Eyewear's high internal standards is it released for distribution. Coloring. Various coloring processes and techniques are available for use. Here follow some examples. Pad printing. Hand spraying. From design, materials, and manufacturing to faces across the world. Stepper Eyewear. Frames to fit the world. Everyone has a distinct face. Finding the correct fit frame for your face is an essential part in delivering the best vision solution. Since 1970, Stepper Eyewear has been observing and recording facial dimensions from people across the globe. This knowledge, combined with technical innovation and a fundamental desire to deliver frames that fit, has culminated in World Fit, European Fit, Asian Fit, African Fit, Alpha Fit. Stepper Eyewear's worldview of frame design identifies 3 key characteristic ethnicity types, plus age-related designs for children. World Fit. These characteristic types apply aggregated facial dimensions across ethnic and age groups and have been created as a guide to finding the perfect frame. Advice from an eye care professional for individual facial measurements and prescription lens requirements, embellished by an individual's style, will result in a final pair of spectacles that is as unique as the wearer. Don't be just a frame stylist. Offer professional advice, as this is where your value lies. Stepper Eyewear. The perfect fit